welcome to the new session that Geology for Civil Engineers. In today's session, we are going to discuss about fault. We discussed the deformation part, that there are different kind of forces acting on the rocks, and we briefly explained that what are these different way of forces which are acting on this, and as a result, so rock breaks or rock deforms. So when it is a ductile kind of deformation, what we are getting is the output is a folding, and when the deformation is kind of brittle, that means it breaks. So that means the rocks are going to break and it is going to move along the broken surface. So that movement, or the rock which is moving along that broken surface, then we call it as a fault. For example, if you see here, it is a cross-sectional view of a rock strata, and I'm going to apply forces on this rock strata. What will happen to this rock strata? It will accumulate that forces for some time. It will have the efficiency to survive that forces for some time, but it will have a point where the forces are not able to, the rock is not able to handle that forces, and it will create some fractures. And if along that fractures, if there is a movement, in that case we call this is a fault. Okay, and in nature, if you see here, this is the rock is a solid rock which has moved along a faulted surface, so we call it as a fault. So what we see here, it is a broken surface. This broken surface, it is a three-dimensional. When we are looking at this at the cross-sectional view, we find it is a straight line or it is a cut line, but it is a three-dimensional feature. Along with that plane, the rock has cut or broken, and it has a movement. So that structure what we see on the rocks, we call it as a fault, and the process of forming this fault in the rocks, we call it as a faulting process. And this is the image what you are seeing from Buch, near the Buch city, where along the road cutting you will be able to see this kind of faulting structures. Now I hope that you will be able to correlate it with the earthquake topic what you have studied, and earthquakes are generated during this process of faulting. So if you remember, what was earthquake? Earthquake is the sudden release of energy. And what is that sudden release of energy? What is that happening here on this rock strata? There are forces which are acting on this rock strata. Now the rock strata is able to accumulate some amount of forces, but it will have some point where it will break and it will move down and it will release that energy. So that release of this energy, here in the animation I have shown, it is in a very smooth process of sliding, but it is not actually happening in nature. What is happening in nature, when we break something, it is a fraction of a second, and all of a sudden things are releasing the energy, and that is a huge amount of energy which coming to the surface, is what we call it is virtually shaking the surface, and is an earthquake. But the earthquakes are produced as a result of the process of faulting. So these are all connected things, and what we see here is a layer of sediments. Okay, sediments which are formed by some agents. Okay, we can see some structures like laminations. We can see some structure here in the secondary structure, that is a fault. So this kind of structures are seen. So this is all together what we are seeing on the screen. This is called a fault, and the process of happening that fault or process of faulting is process of creating a fault. We call it as a faulting process. So when you are talking about the fault, there are different terminologies associated with fault. So the terminologies are something like, the first one is a fault plane. Okay, fault plane is something. So for example, if I am seeing here, okay, so before that we have seen the cross-sectional view, but if you see it in a three-dimensional view, what we see here, it is a surface. Okay, and this is what the fault plane what you are seeing, fault line what you are seeing. But when the rock breaks, it is not a line, it is a planar feature. So this plane or a three-dimensional surface along with the rock fails or breaks, we call it as a fault plane. Okay, so this plane we call it as a fault plane. And when you see these fault planes, usually if it is a normal kind of rock, normal igneous or sedimentary or metamorphic rock, the rock is not going to break as the way you are shown in the animation. It is not like a cut which is going to be a zone, all this area which is going to be crushed so much, the rocks are going to be disturbed so much. So that zone of faulting, we call it as a fault zone. Like in the previous image we see, it is a small fault. So here we can see some area along which that the rocks are crushed. Okay, so this is the zone, this is the area where the faulting happens. Okay, so that area we call it as a fault zone. Okay, so faulting happens, then fault zone. Then there is another area where the faulting in this area, faulting happens in this area is of ductile kind of movement or ductile kind of deformation. So we call that area is as a shear zones. Okay, so shear zones are the areas where the faulting, that is again a region as a zone where the faulting happens, but the deformation is more like a ductile kind of deformations, correct? And here I have mentioned one terminology, this is called slicken slides. Slicken slides are the striations or the lines what we can see on the surface of the fault as a result of movement of disrupted block. When the other block, the second block, when it moves on the surface on that fault plane, sometimes it may create some scratches on the surface. It is like if you are pushing your table on the floor, then the floor may create some striations or the markings. So from that we can identify the direction of movement of the table. Similarly, here it is a rock block, and the rock, when it moves on the surface or on a planar surface or in a region, it may create some kind of striations. So that striations we call it as a slicken sides. Okay, so these are the terminologies what we are usually come across in the faulted regions. And there is one more thing which is important here. It is a dip, throw, and heave. Okay, dip, I don't think that I need to explain it again because we have already discussed. When there is a sloping strata, so the amount which is created by the sloping strata, we call it as a dip, or the amount of inclination of that fault plane. In the previous case, when we studied the structure in the starting exposures, where we had discussed the dip of a strata, that dip was the dip of the bedding plane. Here it is again a planar feature. What is the planar feature? The planar feature is this fault plane, and this fault plane is having an inclination. So that inclination which is produced by a horizontal imaginary plane, we call it as a dip. In this case, both the cases the concept is same. And when these two things are we comparing, so this block, this point, if you take this point was earlier here, which was both together. Now it has slipped to an amount, it has slipped to a new point. Okay, so here if you see in reality, there are two kind of movement or two directions the displacement has happened. It is similar like a civil engineer when you design a step. Okay, when you climb one step, what is happening to you? You are having two kind of movements. One is you are horizontally moving to a level, and you are vertically moving to another level. So there are two kind of movements when you climb a step. Similarly, when it is moving down, this is also having two kind of movements. One is horizontally you moved little bit ahead, and vertically you moved little bit down. Okay, so this horizontal movement we call it as heave, and the vertical movement we call it as throw. So but it is not necessary that every time these all things should be perfectly vertical and horizontal. Sometimes it may move something like this, so where there is a diagonal movement. So diagonal movement also take place. So then we sometimes use the terminology that the slip of the block, the slip of the disrupted block, which includes the horizontal, vertical, and the diagonal displacement. So these are all the parameters. Because why I am discussing this thing, but in today or in the present day situation, when you see this surface, okay, so nothing may be visible on the surface. We will have some trees, we will have some houses, okay, we will have all these things on the surface. But below the surface, when you actually see the character of the rocks, the rocks are having this kind of different structures. So this disrupted rock which has moved down, as a result this much area which is having a different rock type. Okay, and when you are planning to construct something on the surface, you are doing any kind of activity, this area your foundation is going to rest on a solid rock, whereas in this area when you are going for the same amount of depth, that area your soil is, or the foundation is going to rest on a on something is a loose soil, or it is not as same as this X and Y are having different characteristics. Similarly, if you are taking this example, here I need to make a tunnel, and I'm going to cut this tunnel across. At the point when I reach this point, okay, in the fault plane, what happens? The rock type changes. There is another rock, because the rock is what I am expected to get on this part is changed to a new rock type. Okay, so this kind of things happens when you are talking about the engineering aspect of this faulting and the faultings. There are so many other terminologies. We are not going to right now discuss that things in detail. Rather, these main things will help you to identify the actual geological character of the region. Now there is one more thing. There are two things, because when a faulting happens, what is happening? When the fault plane is here, this fault plane is dividing this block, the earlier blocks, into two blocks. What are these two blocks? These two blocks are called wall. And what are these walls? These walls are called, one is called a hanging wall and another is called a footwall. And what is the criteria for dividing this footwall and hanging wall? The block. What is the block? This block I am talking about. This block, three-dimensionally you have to imagine. This block which is above the fault plane. I'm not talking about the fault line. I'm talking about the fault plane. Fault plane matlab this fault plane. Okay. So if I consider this is a fault plane, this is a fault plane. So the block which is above the fault plane will be considered as a hanging wall, and the fault which is below the fault plane will be considered as a footwall. So here in this case, which is the fault plane? This is the fault plane. Fault plane means this is a three-dimensional fault plane. And which block is above the fault plane? This block is above. You have to imagine that you have keeping a slanting plane, and the block is above in this direction. I am not talking in the left side block is slightly above the slanted box if you are taking the vertical displacement. But I'm not talking about that. I'm talking about this block which is placed above this plane. So this block is called a hanging wall. And the best way to identify the hanging wall and footwall, just imagine that the person who is standing here, this is a person who is standing here, this is having his head and he is having his legs. Now the block, when it cuts across, his head will go into this block and his foot will go into this block. So this is called, this we can identify as a footwall, and this we can call as a hanging wall. Here is head goes is the hanging wall, and here is a foot hose is the footwall. Now if I give a small example, here in this image there is a layer and there is a faulting, and as a result the rock got faulted, and this is the remaining resulting feature. So there are two blocks, block number 1 and block number 2. So the block number 2 would be hanging wall or a footwall. Hope you have answered. This is hanging wall. Now there is another condition, same kind of rock layer. There is same, and this rock has moved. This is layer number 1. This is layer block number 2, wall number 2. Which one is hanging wall and which one is footwall? Obviously, hope your answer is the 2 is footwall and 1 is hanging wall. Why? Because this is a block and the layer is above this. So the block which is above the fault plane is called the hanging wall, and below the fault plane called the footwall. Just imagine that you are keeping a notebook, and your notebook in an inclined way, and keeping something on above the notebook and something below the notebook. Okay, so that is the way we have to imagine this. Okay, so I hope that you are clear with the hanging wall and the footwall concept. Now, if you are going to the classification of this fault, there are a number of different ways these faults are actually classified. So, in the classification scheme of fault, if you see, there are classifications based on apparent movement of the block, disrupted block, and there is a classification. There will be classification different on the relation of the fault attitude, the attitude of the displaced block. So with reference to the attitude of the block, and then what happens to the faulting, that also can be a classification based on that. Then there would be a direction of slip, that the amount of direction, which direction which is slipping, and the amount of dip, low angle, high angle, medium angle, and the amount of mode of occurrence also. So these are all different varieties of ways we can classify, but ultimately if you see the faulting, so a primary classification scheme is what we are going to discuss here in this class. So that is based on the apparent or the relative movement of the disrupted block. So the first one is called a normal fault. If I see, the right block is hanging wall and this one is the foot wall. And what is the movement here? The foot wall have moved relatively in the downward direction. As a result, what happened? The extension happens, the expansion happens, the length increases. Correct. So the the hanging wall of the disrupted block has moved relatively down, then we call it as a normal fault. So here this is also normal fault because this hanging wall here is moved down. Here this is foot wall and this is hanging wall, because this is faulting this way, this is above the plane, so this block moves down, and this is foot wall and this is again a hanging wall. All the cases here and here, the hanging wall moves down, so all this faulting we call it as a normal fault. As a result, what it has produced is a structure, we call it as a host and graben structure. So the upward side, the side which is the surface which is exposed, we call it as a host, and the part which is down, or we call it as a graben. And if you see an image, this is an original image. Here we see the top, or the area which is exposed here. This is a graben. This is a graben, or the surface area where it is deeper, and this becomes a host. So this is again a host, and this is a graben, and this is a host. So this is, we call it as a half graben because it is not completely developed, rather it is a half graben. So this is a half graben. So a series of normal faultings produces what? A structure, and that structure is called a host and graben structure. Okay, now if the opposite of that, okay, reverse fault. Reverse fault is what? Where the hanging wall, here which one is hanging wall and which one is foot fault? This is the fault plane, and the block which is above the foot fault plane, we call it as a hanging wall, and the block which is below that, we call it as a foot wall. And what is the relative movement? The hanging wall moves up. When the hanging wall moves up, then the shortening happens. Okay, when the hanging wall moves up, when the shortening happens, so that fault we call it as a reverse fault. Next one, it is a strike slip fault or a transcurrent fault, where neither of these fault blocks moves down or up, rather they are moving in side by side. See, here both the layers, this layer is of same height, there is no displacement vertically, rather the displacement is horizontally. So this kind of movements we call it as a strike slip fault. And there is one more, we call it as a diagonal slip fault, where the movement is diagonal to the layers. Okay, net slip means the amount of slip which happens to these blocks are neither parallel to the strike, or neither parallel to the dip, or neither parallel to the strike. So it is perpendicular, or it is oblique to the slip. So it moves something like in a diagonal manner. That we call it as a diagonal slip fault. Okay, so as a civil engineer, now what are these faults which are going to affect us in the construction activities? Because when I am talking about there is a faulting, means the surface you may not be able to see that thing, but the subsurface there are the changes in the rock. For example, if you see the rock layer which you are expecting to do the foundation is at a depth of 10 meter here, and here in this area that is at a depth of 8 meter, there is a displacement. So these are the kind of things what you are expecting by the faulting. There is an effective displacement or dislocation of the structure, the layers below the surface. So this effect of faulting on rock and how far that is suitable for strength point of view of the foundation or a abutment is one thing the civil engineer should look into when you are studying an area for geological aspects. Then what is the effect of past faulting where we can make the structure? Will it be suitable? We need to take a decision. Chances of reappearing of the movement in the future, because here there is a movement already. So do we have a chance that it will move again in the future? That is what a civil engineer has to decide, because when we see the surface it is smooth, and when you see the subsurface there is a fault, and this whole area is now filled with the soil. Now if you are going to do some construction, it is a normal residential building, I don't mind, but if you are going to do a construction on this area, here this is for example this is a nuclear power plant you are constructing, and you know either you know or you don't know that there is a fault below the surface. Now right now this fault is not moving, there is no movement along this surface, but there are chances this fault can move in the future. So in that case, if it happens, then what will happen? This block will go down. Then what will happen to this this building? That building will also move. This building will become something like this. It will move down. Okay, so this part will stay here and this part will come here. So this is actually the failure of the building, and this we can we as a civil engineer, if you look into this aspects as a normal residential building, it is maybe a small loss compared to a hazardous building like a nuclear power plant or a or any other kind of reservoirs or a dam. So in that kind of areas, this is not at all acceptable, or we cannot afford this movement along this block. So how do we know that whether this movement can happen in the future or not? That is by a detailed geological study of that, and what was the last time it got activated, and what was the last time it got displaced, and how much it got displaced, and what is the present condition of that displacement, whether it is accumulating energy or not, whether there is a chance of movement along that or not. So that will be done by a detailed geological study. Third thing, the safety factors to be considered when designing over a faulted area. Okay, so in this case we have a very good example of our Narmada Sardar Sarovar Dam, which is existing or it is constructed across a fault. Understanding this structure, the geological structures, doesn't mean that you cannot do the construction. It only means that you have to take the precaution what you are dealing with. Okay, if we are taking that precaution, then we can do construct the thing. Okay, so this is what the engineering considerations of fault and fault as a civil engineer we have to take into. And if we are coming back to the especially into the fault terminology, what are the number of different features by which we can identify this faulted strata? Number one, it is a fault scarp. Fault scarp is something like that. This area is slightly exposed. So we'll see this kind of things on the surface where there is a relative displacement. Okay, this block has moved out. Okay, so water is flowing there, and there is a channel which flows here along the fault plane. So that kind of geomorphological features we'll be able to see. Here is a channel which flows, and all these channels will take up a different turn when it is crossing faulted lines. So that kind of geomorphological features we'll be able to identify. So then repetition of bed or omission of bed. So sometimes when we are coming from here, there is a strata which continues. When I come here, that strata discontinues, and that is again an indication of a faulted strata. So this is another indication of repetition of bed. Then the features of silicon slides we have seen. Fault breccia, you know the terminology breccia. Breccia is a coarser rocks which are angular in nature or gravel size particles, so that it actually produced in these areas where there is a crushing and movement, that will be indicating the fault breccia. Myelonites are fine crushed materials, so that is a rock type will indicate a faulted strata. And sometimes what happens, this fault may extend downward, and magma or the molten rock may come up across this region and it will crystallize. So mineralizations on this area will also be an indication of the faulted strata.